Hello, this is Joe Sack, and I am a program manager on the query processing team for Azure SQL Database and for SQL Server. And in this demo, we're going to look at table variable deferred compilation. This is actually a re-recording of the original video because there was a discrepancy in the last demo, so I just wanted to repost the corrected demo. Now, in terms of availability of this feature, just note that this is in SQL Server 2019 public preview, and it also works in Azure SQL Database. I'm going to include actual execution plan for both examples, and let's kick things off while I describe what we're executing, because this is going to take a little bit of time. And if we go ahead and execute this, okay, so stepping through the code. Now we have an enlarged version of Wide World Importers DW, and I'm going to set it to compatibility level 140. So that means we're going to look at the old behavior. Anything 140 or lower, we're going to show this old table variable behavior. And by the way, for the scripts that I'm showing here and also enlarging Wide World Importers DW, you can follow aka.ms IQP demos. And I'm going to go ahead and use the database. I'm going to declare the variable. I'm going to populate it from the fact order history table. So we have this table variable called order. We populate it with a number of rows. And then I'm going to actually join to that table variable. And I'm joining fact order history extended as a table to that table variable based on order key. Now, key point here. Before table variable deferred compilation, and you're starting to see some of the results flow through, but before this feature, what we would do if we had a table variable referenced for a statement is we would compile right away, and we would make a one-row assumption about the table variable. So we didn't know the actual number of rows that would be in the table variable. If you had a low number of rows, no problem. But if you had a high number of rows in the table variable, then performance could suffer. So in this example, we're still executing. This is going to probably take about a minute and a half for it to execute in total. And if we look at the execution plan, the first plan you see here is our actual population of the table variable. And then here's our actual select referencing the table variable. So when I was talking about the one row estimate, if we hover over our table scan of the table variable, you're going to see that our estimated number of rows, it's equal to 1. An actual number of rows much higher. So we're making this fixed row guess, and if you have maybe 1 or 2 rows or 100 rows, maybe your query performance will be fine. But when you have much more than that, then performance issues can happen. So if we look downstream, a few different markers that might be of concern. First of all, we see nested loop as a physical join algorithm selected. Now for a few rows, that's okay, but for many rows, this could be problematic. Now, another little warning right here, if we go over to the sort, you're going to see a sort warning, and you're also going to see that we're spilling to disk. So operator used tempdb to spill data during execution. So we have that problem. Now, again, this is all based on that one row assumption, and then downstream it causes bad side effects. Now, in table variable deferred compilation, I'm going to kick off this example as well because it'll still run for a few seconds, but we should see a performance improvement. And by the way, before I kick this off, let me just go ahead and show you the execution time. So if we go to query time stats, you're going to see an elapsed time of almost 75 seconds. All right. Now, let's go ahead and kick off the same batch. And this time, we are running under compatibility level 150. And one thing to realize about this feature, so all we're doing here is just saying, you know what, instead of making that one row assumption, for the initial compilation, we will use the actual row count that was for that initial compilation. So if we have 500 rows for that first compilation, that is the plan that gets compiled, and the downstream operations from that table variable will make that assumption of 500 rows. Now, if you're oscillating back and forth, 1 row, a million rows, 1 row, a million rows, then you're still going to have issues because of that parameter sensitivity, or if you have another scenario where it's just something that is a different row count based on the conditions of an order ID or a particular store or a customer. That's still going to be a problem. But if you have a consistent row count and it's greater than 1 row, maybe it's thousands of rows or millions of rows, and you have this compiled plan that's used for that for consecutive executions, then you'll see performance have a gain with this feature. All right, so going to the execution plan, First thing you'll notice right out of the gate is we have a different plan shape, a few different markers that have changed. We see that we're using parallelism. We have a different join algorithm, hash match. We don't have a spill for the sort. If you hover over actual order, you're going to see we're no longer guessing one row, and our estimate is actually equal to our actual number of rows. And then most importantly, if we look at the select, let's right-click Properties, look at Query Stats, and if we look at elapsed time, we're looking at 49 seconds now. So we see a performance improvement compared to the original. I think the original was 75 seconds or so. And so with that elapsed time improvement, obviously that's the most important thing. And that was just an example for table variable deferred compilation. If you want to learn more about it, you can see our intelligent QP documentation here, aka.msiqp. And then again, for demo scripts, you have a link. And any questions or feedback, feel free to email intelligentqp@microsoft.com. Thanks.